Hello everyone, welcome to my channel on engineering mathematics. In this video, we are going to see how to find inverse Laplace transform using first shifting theorem. Guys, I have already discussed this technique in my previous video. Link of that video is given in the description box. But still, I would like to recall few points of this technique. Let us see. First of all, we recall first shifting theorem. It states that if Laplace transform of f of t is equal to phi of s, then Laplace of e raised to minus at into f of t is equal to phi of s plus a. Now, operating L inverse on both sides of this, we get e raised to minus at into f of t is equal to L inverse of phi of s plus a. Note that since L of f of t is phi of s, f of t is equal to L inverse of phi of s. So we replace this f of t by L inverse of phi of s to get e raised to minus at into L inverse of phi of s is equal to L inverse of phi of s plus a. Now rearranging these two terms, we get L inverse of phi of s plus a is equal to e raised to minus at into L inverse of phi of s. Which means if you want to find out inverse Laplace of phi of s plus a function, then it is equal to inverse Laplace of phi of s into e raised to minus at. This phi of s is obtained from phi of s plus a by simply replacing every s plus a term by s. Similarly, L inverse of phi of s minus a can be written as e raised to at into L inverse of phi of s. That means if you want to find out L inverse of phi of s minus a, then simply find L inverse of phi of s and multiply it by e raised to at, where phi of s is obtained from phi of s minus a by replacing every s minus a in phi by s. I hope you understood this. Now let us see examples. In this example, we have to find L inverse of s plus 2 upon s square plus 4s plus 8. Let us look at its solution. Guys, note that in this function s plus 2 upon s square plus 4s plus 8, I see these two terms s square plus 4s when added with 2 square return s plus 2 the whole square. So this additional 4 can be adjusted by simply writing this 8 as 4 plus 4. After which denominator becomes s square plus 4s plus 4 plus 4, which further can be written as s plus 2 the whole square plus 4. Now observe that every s in this function is now in addition with 2.